We're going to be learning about vectors. So as we learn about vectors, a vector looks like, from geometry, a ray, where you have an initial point and then it stops. Whereas a ray in geometry goes on forever. Think about a flashlight, where you turn the flashlight on and the light goes on for forever. It looks like that, but in reality, you've got an initial point, which is where we're going to start. And then you've got a terminal point, which is where the vector ends. Okay? And I have got a few different ways to note this. I can use, it looks like greater than, less than symbols. And just like XY coordinates, the first number you see will be a horizontal change, and the second number you see will be a vertical change. So I can use standard vector notation, which would just be A, comma, B, or I can use position vector, which would be A, and then I, plus B, J. And notice I put little hats on my I's and J's. First of all, this is not the imaginary I. This is a position. It's telling you where to go. So I tells you left, right. J tells you up, down. And when you're seeing it typed, you'll notice that it's bolded. So for instance, I've got some vector notes here. And it's, if you've ever seen Airplane, that's supposed to be funny. Okay. So what you have is A times I plus B times J. But I can't bold things when I write. I cannot bold things when I write, so I've got to note it some other way. So I'm just going to put little hats on my I's and my J's, and that lets you know. And then I can name my vector V, and then we put a little bar across it with kind of like a little half arrow. And again, if it's typed, it's not going to have that. But if we're writing, we've got to have a way to note that. So I can have vector V, and then I've got components. So this is my horizontal component. And I know it's horizontal because I tells me it's horizontal. Okay, and I know that this is vertical because J tells me it's vertical. Or I can write it as AB. So these are just little sideways brackets. And again, they look like the greater than, less than symbols, but they're not. They're brackets that tell you that this is a vector. So when we are doing this, a vector has both magnitude, which is distance, its length. So if I've got magnitude, which is distance or length, and we can also call that the modulus, but it's rare that we call it that, okay? But we've got magnitude, which is the distance or the length of the vector, and then we've got direction. So it's important to know which way it's pointing, okay? So we have direction, and if you've seen the movie Despicable Me, then you'll know that there's that little guy who wants to be a superhero called Vector, because he has magnitude and direction. Okay, so you'll notice some similarities in polar notation, in different types of notations as we go through here. So these notes are actually in progress. They're going to change from what I've typed up here. I've already got them, and so you'll have I've got these uploaded in Canvas, but I'm changing them. And so when I upload them, it'll say updated notes, unless you are watching this and it's not June of 2021, in which case I would have already updated it. So the magnitude, if you'll notice, it's just the length of your vector, and you're going to find that using Pythagorean theorem. My position vector is going to be found by the change in x's, followed by the change in y's. And then I can have a unit vector, which is in the same direction of v, in which, I'll kind of explain that later, but you just take whatever your vector is. So whether I'm using the algebraic position vector, or if I'm using my unit vector notation, whichever, okay? What you'll find out is that its length is 1, so we'll go through that later. But also notice this should look familiar, because this is r cosine alpha plus sine alpha, or cosine theta, sine theta. So this looks suspiciously like polar notation. And then the rest of that we'll go through later. But what we want to look at now is just some basic terminology. So if I have an initial point of x1, y1, and a terminal point of x2, y2, good heavens, y2. Okay, so my initial point is x1, y1. So this is just a coordinate. Okay, then my terminal point will be x2, y2, which my hands are doing other things. So let's just make something up. If I have something to the effect of a 3, 7, and a 6, 13. Okay, so if I graph that, what I have is a 3 and then 7. So that's my initial point. And then my terminal point, and you'll be told which is initial and which is terminal. My terminal point is 6, 13. So I'm going to come over here at 6, 13. Then my vector looks like this. Okay, so I want to write this in vector notation. So the way I'm going to do that, if this is initial and if this is terminal, is I'm going to take terminal minus initial. You always do terminal minus initial. So I can write this as x2 minus x1 and then y2 minus y1. Okay, so what I have is x2 is 6 minus 3. So what you found out was you went over 3 units, okay? So 6 minus 3 is 3, and then 13 minus 7 is 6. So I went over 3, up 6, okay? And now I can find the actual magnitude of that vector by just completing the Pythagorean theorem. So I've got 3 squared plus 6 squared is my magnitude. So we'll just say hypotenuse squared because I drew a triangle. So that gives me 9 plus 36 is hypotenuse squared, which is 45, which is hypotenuse squared, which is going to be 3 root 5. Okay, because it's 9 times 5, and you pull out the 9 and make it a 3. So my magnitude of V, so this is V, and the way I write magnitude is it looks like double absolute values. But it's not. It's double vertical bars. So it's not the absolute value of the absolute value of V. It's the magnitude of V. How long is this vector? So again, my vector is that red thing. And that vector is 3 root 5 units. So what we do is by writing it in vector notation, instead of having this diagonal that's running around in the middle of nowhere, is I make it a position vector, which means I can orient it from the origin. So from the origin, I can go right 3, up 6, and then this becomes xy coordinates. I went right 3, up 6. But this is a vector. So when I say it's a position vector, I'm just orientating it from the origin, but it's moving in the same direction as that initial one is because my ratios, these are proportional. So my ratio of 6 to 3 is still 6 to 3. Okay, so it still has that same direction. Now, that's your position vector. So my position vector is 3, 6. If I want to change that into a unit vector, what I want to do is take each component and divide it by its magnitude. Okay, what did she just say? That means this first component is a 3 divided by the magnitude. Okay, my second component is 6 divided by the magnitude. So when I clean this up, I end up with a unit vector, which we'll call U, of 1 over root 5. And we'll say it's on I. Okay, so I'm just giving you some different notations here. So this is horizontal change. Plus, that gives me 2 over, I put a 2 there, sorry, I was reducing it in my head. 2 over root 5. And we can rationalize and all that kind of stuff, but I'm not going to. What I want you to see is that I've got a same vector, but instead of having a magnitude of 3 root 5, my magnitude is going to be 1. Okay, forgot my J hat. My magnitude will be 1. So let's find the magnitude of this. What that means is take your horizontal component and square it. So I get 1 over root 5 squared plus 2 over root 5 squared. So that becomes 1 times 1 is 1. Root 5 times itself is 5. 2 times 2 is 4. Root 5 times itself is 5. 1/5 plus 4/5 is 5/5. And the square root of 5/5 is the same thing as the square root of 1, which is 1. So all you've done is scaled it down so that your actual hypotenuse then becomes 1 unit long. Okay. I can also, there's a third way to write these vectors. So this is your standard algebraic position vector. I can write it as a component vector. So I and j are my components. Or I can write it in my polar form. So your polar form is going to be the magnitude of v times the cosine of alpha on I plus the sine of alpha on j. And notice this is not an imaginary number. It's a component. Okay, so I didn't all of a sudden flip-flop imaginary numbers around. This is I hat. So it's a component. This is horizontal and this is vertical. Okay, so knowing these things, we can then go through, I pretty much went through this. Let's just do 1 or 2 more examples. And so we should also talk about what it means to add and subtract vectors. So if I'm going to add 2 vectors together, what is that going to look like? So I'm going to go ahead and write on this cool paper. Okay. So I have these 2 vectors and I want to add them together. I want to know what v plus w is. So notice that w, how did I get it? I went 1 over 1 up, 1 over 1 up. So this thing has a magnitude of, that's not 1, okay? So what I can do is say, if I want to know what v plus w is, so I know I'm like zoomed in. So if I want to know what vector v plus vector w is, what we're going to do is think about an airplane, okay? So the pilot gets on, v is first. So the pilot gets on the flight, he takes the airplane to his destination, and then he picks up a second flight, okay? So his second flight is going to go this way, like this. So that's w. And so I add that together. Well, in reality, where did he end? Where did he stop? So in reality, when you add those 2 together, you get this final thing. So in reality, the pilot started here and ended here. That's the start. That's the terminal. Get it? Terminal. Okay. And so this vector right there is what happens when you add vectors. So let's look down here. Okay. I add vector v, so that's the pilot's first flight. He picks up a second flight. And so where did he really go? He went from here this morning and he landed here tonight. So that red vector is what happens when you add those together. Now what happens if I subtract 2 vectors? So I've got v minus w. Okay. If I subtract 2 vectors, well, what happens if you negate a vector? So look at it this way. What happens if I have v plus negative w? That's the same thing as v minus w. So what we're going to do is flip-flop w. In other words, instead of w, looking here, instead of him moving right and then up, he's going to go left and then down. So we're going to flip him. So this, if that little arrow wasn't there, it would look the exact same, but the arrow is going to be on the other side. So I need to count this off. We've got 1, 2, 3, 4, 5, 6, and up 2. So we're going to go down 2, and then 1, 2, 3, 4, 5, 6. So right there where that v is, I'm going to take this and draw it to v. Okay, so what did my pilot do? He went this way, and then he backtracked. Okay, so he reversed his course. So when you do that, where did you really truly start? Where did you really truly end? So I'm looking for that red vector right there. So when I look for that red vector, I find out that here's v. I negated w. And so instead of going up and right, I went down and left. So here's down and left. And then that red vector is actually how the pilot traveled from start to finish. We start here, we end there. That's our answer. Okay, so we'll come back and we'll do a few more examples.